Hello, everyone, wherever you are joining us from. Welcome to this week's Believe in Serverless live stream. I am super excited to introduce this week's guest, something I'm actually super passionate about here in the Believe in Serverless community. Although we're the Believe in Serverless community and serverless sometimes does get equated to AWS, there are obviously a lot more clouds doing serverless things than just AWS. And I've recently had the pleasure of starting to work with some of the GCP services. So it's incredibly exciting to have, probably when I think of like GCP experts, at least who I know, this name comes to mind almost every time. Actually, I had the joy of seeing him speak at Serverless Days Manchester a couple of weeks ago. So let's welcome to the stream Paul Gledhill. Paul Gledhill. I don't think I've ever asked how I pronounce your second name. Is that right, Paul Gledhill?
It is Gledhill. Yes, indeed.
Before we get into the stuff about GCP, Paul, do you want to just kind of tell everyone who you are, what you do?
Yeah, certainly. Paul Gledhill. So I work at Lloyds Bank as a lead DevOps engineer, and my primary focus is working as part of the cloud platform team, really enabling GCP products for use across the bank. And in my particular case, that product is effectively just Cloud Run. So I'm trying to bring a little bit of serverless container joy into Lloyds and really kind of beat the drum.
Nice. It's it's like I say, I always get really excited when I get to see other clouds after spending 3 years at AWS and then stepping out of the AWS bubble. It's been really cool to start playing with other clouds. Google Cloud Run being one of my absolute favorites. So how do you want to do this? Do you want to tell people what Google Cloud Run is now? Would you want to share your screen? Do you want to get into stuff? Like how do you want to do this?
Yeah, so I think we flip it slightly. So I really want to talk about running GPU-enabled workloads in serverless in Cloud Run, okay? And so I probably want to spend a bit of time just going through a little bit of LLM basics. And I'm going to hold my hands up here. I'm still learning, and I'm trying to learn as fast as I can. So I'm hoping what I say is accurate. More than happy for people to kind of shout at me afterwards if not. But I just want to also, I guess, just show people how easy it is to start playing around with some of this stuff. So I did a talk at the Google Developer Group in Manchester a few weeks ago, and I covered a whole host of stuff. So let's just talk about some of the things that everyone's played with, right? So and if I am going to share my screen, and I'll just touch on a couple of slides that I did have actually, just to set a little bit of context. So hopefully that's going to be sharing. Okay. Oh, I can't hear you now, James. All good? Fine. Right, brilliant. Okay, so we're kind of getting used to all of these AI services, and we're using a hell of a lot of them in a kind of a managed way. So I'll make that full screen so we can actually talk it through. And that could be just image and text stuff like using ChatGPT or Copilot or Gemini in the kind of Google space. We're using it for coding, GitHub Copilot, Cursor, a whole plethora of opportunities there. There's coming out some multimodal stuff that I find the Google's Notebook LM solution really weird. This is a thing where you give it a lot of different sources and it'll generate a podcast, 20 minutes of two people talking about a subject who are all virtual and don't really exist, and a whole number of other different solutions. And they're all you manage services in terms of interacting with LLMs and GenAI stuff in general. You can interact with them via programmatic means. So if you've got ChatGPT, you can go into the website and you can grab an OpenAPI key and you can start asking it questions using curl commands. And obviously, if you can do a curl command, you can start integrating that into something you've written, a little hobby project, whatever it might be. I'm sure there's plans so that you can kind of scale this up, but you can start then to build that kind of programmatic interface into some of these models and see what you can do with it. The one I want to talk about, because we're going to hook into a little bit with Google and some of the API calls, is I'll talk a little bit about Vertex AI Studio. So Vertex AI is kind of the placeholder product name for a lot of the different AI and machine learning products that sit in the Google space. And in Vertex AI Studio, I've signed up for a Google account here. I've gone into the product page, and I'm going to click on Open Freeform. And in here, I can try out a whole different set of prompts, and I can insert media. I can make it multimodal, and I can try out different models. So I can add in things like here, you know, how do I run an exceptionally cool podcast? And this one's just using Flash, which is kind of a quite a general purpose model that Google have got. You can say where you want to run it, and you can run it fine. And it's just going to come back as you're kind of used to by now, the kind of ChatGPT style. It's going to then come back with a whole set of content that you can dig into.
Does it sound like it's an exceptionally cool podcast?
Indeed, indeed, and I think, yeah, and I think for me, with this, I think it's really nice to be able to see the different kinds of models that Google allow you to hook up in this kind of way. So anything that I'm asking it here, I can create an API call and call into this.
Yeah.
And it is paid for per request, right?
Yeah.
So depending on your definition of serverless, this is serverless.
Yeah.
You know, I can hook these things in. It scales to 0. It scales up. I don't need to worry about anything. Google will just look after it in the background, right?
Yeah. And did I see? Is my audio working right now? Can you hear me? By the way,
it's a little bit hit and miss.
Yeah, I'm trying to work audio issues out. Did I see there's third-party models in there as well?
Yeah, there is. So you've got a whole set of different variations of kind of Google's models, and their Gemini ones are the ones that are kind of they keep themselves. But then you've got third-party models in. You've got your Claude's in here. You've got Meta's Llama models in here. You do have some of those, and so these are all of the ones that are properly hosted. You know, so are absolutely kind of per request, if you like. Yep. Okay. And they're good at different things. Some are good at coding, some are good at generating pictures, etc. Fine. The other offerings that you've got in, and I'll show you this being called in a second from an API call, just to kind of prove that you can do it from the command line. The other things that you can do with Vertex AI is actually you can hook in other models as well. So obviously they were things like the Gemini ones, or the kind of core models that Google are trying to provide on a kind of per request basis. But then they provide hundreds of different models. I think there's like 108 different foundational models and more besides there. That you can actually, if I click on this one, come into Gemini, you can actually look at the details of this, and then that's in Vertex AI Studio. But if I go to DeepSeek, which I'm sure people have heard of, you can come in here and actually they'll allow you to deploy it. So they'll take a model engine, and they'll take the model, they'll pull the model in, and they'll run that in some compute somewhere for you. Okay. The only problem with this, and this is Vertex AI endpoints, is when you click the next page, you get to choose the model and the size and these kind of things, but then it's starting to ask for machine specs, and these machine specs are quite big. So you're talking, this got 4 different NVIDIA GPUs, 80 gigabytes of memory in that GPU. This isn't going to be very cheap. And so some of these options, you very quickly get into the hundreds, thousands of dollars an hour kind of scale, which is all a little bit scary for me, which is why I'm kind of pleased that it's grayed out.
Yeah. Yeah. So there's a question in the chat, just to jump in, Paul. Sorry. So Daryl's asking, there's likely not any OpenAI models then. So can you get access to the OpenAI models? I think that's the question, if that's what I'm understanding you right, Daryl.
Yeah, so not that I'm aware of, no.
But it looks like there's a lot in there. I mean, I can see Anthropic, I've seen Meta, I'm assuming that's Llama. So it looks like there is a whole bunch of stuff in here. There's just no OpenAI, I guess.
Yeah, it's all, and that's all down to how closed shop they want to be in terms of allowing you to run them. So Gemini, for example, you're only really going to be able to run in the Google space because that's their kind of proprietary one. Gemma 2, I went to a really good workshop this week actually, and last week. The Gemma series of models are kind of Google's more open source style models.
Okay.
And again, there's a whole variety of them. Some really good at generating images, some really good at text to text, some really good at solving code problems, etc., etc.
Yeah.
Some they've tuned to be a guard to models, so they'll guard at the front door and they'll guard at the back to make sure that input that's been sent in is what it should be, and also that you're then not sending anything back to customers.
What do you mean by guard?
Sorry. So what they've done is, if you imagine prompts being sent into a model, let's say a prompt's been sent to Gemini, they've then highly trained a version of Gemma 2 to make sure that people aren't trying to do nefarious stuff with the prompts that they're sending in.
Like a model that's monitoring the model type thing.
Yeah, exactly that. And you're getting some really interesting things here where you're getting very specific tuned models that are doing different bits in a pipeline of execution.
Yeah, where's the model that's monitoring the model that's monitoring the model? And this feels like we're on a downward spiral or an upward spiral, depending on which way you look at it.
Yes, and that's the thing, isn't it? I think there's a lot of AI on top of AI on top of AI, and I think you just need to be very cautious of that moving forwards. Yeah. Okay. So I'm going to dip into some code.
Is it Rust?
It's not Rust. It's not Rust. In fact, I don't think there's any coding language style stuff in here, right? So I'll share this repo afterwards.
Yeah. Could you just zoom it in just a touch?
Yeah, of course I can.
Lovely.
Like this? Yeah.
Yeah,
brilliant. So I'll share the Cloud Run GPU demos, and what it's got a set of local machine demos first. And I mentioned about, I think that not everyone understands quite how simple it is to get some of this stuff working on the local machine. So I'm going to be using Llama, which is by Meta. And Llama is a model host, okay? Think of it like a web server, an app server, okay? Can't do anything by itself, but it helps to host models so that you can query it in a standardized way, both via the kind of CLI and also via APIs. And a macOS brew install will get you it installed. For those who prefer a Windows-based system, you can use a winget, and again, it'll come down pretty quick, okay? And once you've got it down, and again, I will make this big enough, but we can just get the server up and running, Llama serve. That binding's already in use. It's already up and running. Brilliant. Okay. And then if I want to run Llama 2, this is confusing, isn't it? So Llama's then the Meta's model. Sorry. Maybe should have picked a different one. But if I want to run that model, then if we get the number of L's right, I can just do a run. Now, I was trying to turn debug off before we joined the call, but I couldn't. So ignore everything above here. What you should get is a really nice, crystal clear send a message text box. Okay.
Yeah.
And that is the prompt. So I can then say, again, how do you run a successful tech meetup? Okay. And now, what you didn't see here is the fact that when I first ran Llama Run Llama 2 a few days ago, it had to go and download a 5 gigabyte model file from the internet. Okay, so it's obviously very sped up on this. It had already cached the model, but when I type that in and hit enter,
nice.
This is sufficient to have a model running locally on your machine. And when I was in Manchester, I could disconnect Wi-Fi and show people you didn't need internet connectivity, but I feel on a podcast that wouldn't work.
Yeah, we're going to lose you. Don't do
Okay.
that, please.
Right.
I could talk aimlessly for 5 minutes while you come by. But we don't want to put people through that. People want to learn about GPUs. So if I can just check exactly what's happened here then, because the all llama and llama thing has confused me in the past.
Yeah.
So all llama is almost like a host for you to be able to run a model.
Correct.
And then Llama 2 is the model itself.
It's the name of the model. And actually, look, let's do it slightly different. If I did another Llama, then this time I actually run DeepSeek instead.
Yeah.
There's a little bit less contention, isn't there, naming wise?
Yeah.
And I'm not going to try and write that. And again, I accessed it a few days ago, so the model file is already on my local machine.
So just a follow-up question then. So all of this is running inside your machine, right? Nothing's leaving your machine in this setup. Is that correct?
Absolutely correct, and I think it's bonkers.
Yeah, I mean, and that's that. I mean, at least for me, like one of the, regardless if it's DeepSeek or an American AI company, like at least when I thought people would be personally, like, there's some things where I'm like, I don't want to put that in a third party's hands in any way, shape, or form. So I guess this means everything is completely self-contained inside your machine, right?
Absolutely. Yeah, absolutely. And that's really nice, right? So it's not going via a mobile app that has some vulnerabilities or being served on someone else's. It can't be used to train anyone else's model. So all of those concerns people have about, I'm putting my own data in. It's like, well, it's not going anywhere. It's just on this machine. Yeah.
This DeepSeek is going hard on the meetup advice, by the way.
It'll run for quite some time. So if I stop it, I think in here somewhere I've got a screenshot. So I asked DeepSeek a question, and then I asked Gemma 2 the same question. And because this is using the GPUs on my local Mac, I went into Activity Monitor, and you can see the length of time it takes DeepSeek to think about what it's responding to, and that is all the way through. It's sending all of those letters and tokens back to your screen. It just maxes out everything for that entire length of time.
And that's where you've asked DeepSeek and Gemma, was it, or Gemini, the same question?
Correct.
It's taken DeepSeek what, 3, 4, maybe even 5 times the 5 times.
Well, 7 maybe time. I mean, it's a lot. It's a hell of a lot longer, isn't it? Yeah, absolutely. And it's just it's part of that is the kind of the detail level in the models, and then part of that is just the way DeepSeek has been set up. It continuously questions itself. It really rips apart what you've asked it into its kind of foundational elements, and then tries to put those together.
Yeah, nice.
We talked there about kind of, I guess, the kind of how deep it went and the quality of the response. I guess it is worth also just mentioning that with these models, you normally see models with things like this on them. So you've got kind of the name of the model as it was built when it was learned, and then your 14B is 14 billion parameters. So that's kind of how complex the model has been asked to be when it's been built. And you need to the kind of the ones that they host in the kind of main DeepSeek kind of service. I think it's something more like 130 billion parameters. So it's you have to match your kind of capacity of your machine to the model that you're actually running. And there's mechanisms for making them smaller to kind of fit, but you just need to kind of bear that in mind. I've got an M2 MacBook Air with 16 gigabytes of RAM. So I found that this is about as big as I can.
Okay.
As I can.
And I guess that size is enough for the vast majority of tasks.
Yes. Yeah. And you'll see, the quality differs, and it would definitely be enough to prove things out as well. So if you're wanting to do local testing of sort of solution that you've written, then, it would be enough to kind of prove a lot of those pieces. Yeah. Nice. Okay. So we've done a little bit of the local machine testing. Maybe don't want to spend too much time on the API stuff, but when we were talking to when we're using Vertex AI a second ago on the browser interface, so when we're in here and we're inside the freeform editor, when we're sending it queries, you can do that just using effectively an API key. So with this one, I'm choosing the model I want to use. I'm going to use Gemini 1.5. I'm going to get the project ID. That's my project ID out of G-Cloud, which is Google's main CLI tool. I've chosen the region, Europe West 4, just because that's where I put all of my samples. So I'll set it up for that. And then I'm just going to send a curl request. Let's try not to boost. So authentication token, it's going to again grab that out of G-Cloud. That's based on my credentials. A little bit of JSON in here. It's going to pass it into the Google APIs, and it's just going to put a prompt in. What's the best way to introduce serverless technologies into the enterprise? And then out the back of it, because it outputs in kind of JSON that's formatted in a certain way, I'm just going to use JQ to kind of grab that out. So if we just do a quick one of those, and again, let's try and make this a bit bigger.
It's interesting, just as a quick side note while that's running, that the auth to Google APIs is just JWT as opposed to like all the AWS SIG v4 access tokeny type stuff. It's quite interesting that it's just a bearer token. Feels much simpler.
I think that part of that's just the time and when it was introduced as well, isn't it?
Yeah.
Google anyway. Again, so it's returned a response out. It's in Markdown format, and it took about 5 seconds for it to respond to this particular request. So this is effectively pay for prompt, and this is using Gemma 1.5, which is all kind of text to text based stuff.
Yeah.
What I really like is if you go to experimental, Google have a whole set of experimental APIs that you can access.
Nice.
And what I like about these is that they're free to use. So there's absolutely no charge. The problem is that they change them quite often.
Okay.
So the day before my previous demo, they updated this and removed an old one and introduced a new one. But if you want to do some quick dev and you don't want kind of any costs to get incurred, then it's a good.
That's really nice, actually. So if you're deving and you're not actually that fussed.
Yes,
it's very cool.
Yeah, I do kind of like that. And you've got a couple of different versions. You've got the kind of Gemini 2 base, and then you've got the thinking one, which is a little bit more DeepSeek-esque in terms.
And I suppose when you say they're changing, they're not changing the way you'd call the API, right? It's the quality, the response. So you'd still call it in the exact same way. All you're doing is just subbing out the model ID.
Exactly that. So you change this.
Yeah. So you might just get some unexpected results, I suppose, when you move from one thing to another. Yeah. So from like a code perspective, I'm thinking if you were running this in like a production system, you're changing an environment variable, changing a configuration setting between, hey, it's free, hey, it's not free. Yeah. Which is really cool. I'm thinking like even thinking beyond like local dev, I'm thinking for like dev environments, if you just want to test that your AI thing does a thing that you expect it to, and you're not that bothered about the specifics of the response, that's quite a nice way. I don't know if Bedrock does the same thing. Actually, I don't know if anyone listening knows, but I don't know if Bedrock has a similar kind of thing where it's free for certain stuff. But that's very cool, all the same.
And then you can change from 1.5 to and again exactly what you're just saying. So it's using version 2 Pro Experimental. That wasn't in the list we just saw. So this obviously was one of the ones I was running the other day. But yeah, nice to be able to try these things out. Obviously, the models aren't just about generating text. So you can come in here and we can run. Again, hopefully it's big enough. But this one, and I promise I'll get onto Cloud Run in a second. But this one's just running, create me a picture of a flower. Okay, so it's text to image. So there's a prompt. But again, it's the same. Most of these, they've tried to standardize, haven't they, on the terms of the interface and the API into it. Mm-hmm. And then it's just how you kind of access that out the back of it that changes. So if I do code, do the flower PNG. There we go. And then you've got the flower that is generated out of the back. Obviously, that was over an API call, so you could have integrated that into something, etc.
Yeah.
Okay. Great. So we've set the scene a little bit. We've done local. We've done some APIs. So let's start talking a little bit more about Cloud Run. So before I dig too much into the demos that I've got, so Cloud Run is Google's container as a service service. So if we come in here, and we go into Google Console and we come into Cloud Run. You can see in my Playpen environment, I've got some services already, but this is where effectively you want to deploy a particular service. So Alarma actually have their own container image. So I could use the Alarma container if I wanted. We can give it a service name, different one. We ask it what region we want to run it in. I'm going to very specifically go Europe West 4 because that's where I've got. Yeah, absolutely. So I'm gonna tick a box in a minute that says GPUs, and GPUs are still in public preview.
Yeah,
and you need to request a quota to be able to use them.
Yeah,
and that's the only region that I've got any quota.
Okay.
So my guess would be, as it's been in public preview a while, that it's going to come out of public preview relatively soon. But at the moment, you do just have to go through that hurdle if you want.
Is that easy enough to do for anyone listening who is interested in doing that? No, you don't. Yeah.
No. So you go in, you'd search for quotas, and there's a particular quota, and you just it'll be at 0. You can request. I requested 4. They gave me 3. Felt like they should try and knock me down some, but didn't knock me down a huge amount. And it's about a 2-day turnaround.
Oh, right, okay.
Something like that with a little bit of requests. So not bad, not instant, but yeah. So yeah, you can still start playing around with them, but I think it'll come out. They also do that with certain sensitive. I don't mean sensitive in terms of privacy. I mean more cost sensitive. So some of the larger normal GPU instances against compute instances, or certain services that most people don't use, they'll put a quote on there just so you have to check with them that you're doing it for the right reason. Yeah. In here, I'm going to click require authentication. I'd rather not just open an endpoint up that anyone can call, and I'll show you how I can use a proxy in a second to make that relatively quick and easy. Request-based billing. This is a slightly tricky bit. So normally with Cloud Run, the billing's done 100 millisecond blocks, and you only get charged whilst it is processing requests. Once all the requests have been processed, that instance stays warm for up to 15 minutes. They can terminate it earlier if they want to, but up to 15 minutes, and then they'll spin it down. But you only get charged for the request at the beginning. With GPUs, they've said that they want you to be on instance-based charging. So for that full 15 minutes, you would get charged even if you only used it for a few seconds at the beginning.
Yeah.
And that, for me, I get it, just because for GPUs to be usable, you kind of need to get data into them. And so you're going to have to put 10, 15, 20 gigabytes of data into the GPU to get it running and being usable.
Yeah.
So it's worth understanding that one.
When you say, is it a prerequisite that you have to select instance-based, or you can select request-based? They're just like, please. Like, is it? No,
so I think it'll tell you off. So let's leave it at request, and then let's see if it tells us off in a second. Okay. I'll leave it to scaling, leave it at 0. We come in here into how you configure your containers. I'll just do a port 8080, and here we go. So this is the little preview box,
and
it's gonna moan about a few things. One is that it needs at least 16 gigabytes of RAM allocating to the container.
Yeah.
In Google with Cloud Run, memory and CPU are separate, and again, it's saying you need a minimum of 4 CPUs. Okay. And then here, instance-based billing.
Yeah.
Okay. So
like you say, you get it. I get it. I don't understand this world too much, but I can understand why they'd want you to commit to a certain period of time for have something that's reasonably scarce and reasonably intense to use.
Yeah, and I don't know if they'll change that moving forwards. Once they start getting used to how people want to use it, there might be slightly different models with it. I think they're still learning a little bit in terms of usage patterns. Because the other things are, for example, GPU type. Currently, we're just limited to an L4.
Mm-hmm.
Now, if you're anything like I was, you're just going to be scratching your head at that one. So let me quickly put this up. So this is an L4 chip at the bottom. So it's NVIDIA L4, 20 gigabytes of memory. Mainly good for inference. So it's good for providing those answers once the model's already been trained and it's just running the model.
Yeah.
Google provide access to all of these other types of GPU against compute instances.
Yeah.
And you can see 141 gig at the top here. I think it'll be interesting. I think they might add a few more, but with Cloud Run and its kind of instant compute, I think they'll probably focus more on the inference type of learning, inference kind of use cases, rather than like use cases where you might need this to be running for 8 weeks, 6 weeks to do some like proper training.
Yeah.
And then number of GPUs, 1 today. As a maximum. Again, I could see them allowing that to be increased moving forwards.
Yeah. So while there's a question that's coming from LinkedIn, Paul, and it's, is the all armor you're using within Cloud Run coming from your local machine? I think I would understand that is where is that going to come from? I think.
This one here.
Yeah, exactly.
Brilliant. So this one is it's a Docker image.
Okay, so
coming from Docker Hub. Okay. So it is just it's just going to be.
Yeah, cool.
It's just going to be one of these.
Whatever you put in there, it'll just pull it from. Can you specify other container registries? I know Artifact Registry there, which I think is Google's, but can you? Okay, yeah.
That's interesting. I've never tried anything other than Artifact Registry or Docker Hub.
Either pull from a Google Container Registry or a Docker Hub. Like, I don't really know where else you'd want to pull one from, unless you were doing that cross cloud stuff and pulling it from like ECR. But anyway.
I think you'd normally want to have a flow, wouldn't you, where it's pushed close to where it's going to be used.
Yeah, I think if given Cloud Run's going to be starting stuff up on the fly, you'd want the container image to be as close to Cloud Run as possible. I would have thought. Like, I don't know why you would do that, but anyway,
I think it has its own internal cache of the images that you've gone through with this. But okay, good question though. But to be really clear, so this is a container image. Okay.
Yeah.
It's Llama container image.
So imagine like hub.docker.io / before that.
Yeah. Exactly that. Exactly that. Okay. Other little settings we put in here. I don't want to cover everything, but it's normally the maximum number of instances is 100. That's the default with Google Cloud Run.
Yeah.
They give you a default quota of 1,000. Yeah.
Yeah.
I do know a certain broadcasting corporation who managed to set some of theirs to 15,000 after conversations with the CSP. But it's complaining at this one because actually I've only got a quota of 3. So 3 is the maximum number of instances I'm allowed to spin up.
Yeah.
Because it's 1 GPU per instance. But you can have multiple requests per instance.
That was going to be my next question.
It's different. It's different to Lambda in that sense. So here you can see maximum concurrency of 80. Doubtful you'd hit 80 before it started trying to kind of scale up. But you can have multiple requests concurrently against them.
So for anyone familiar with AWS Lambda or not familiar with Cloud Run, so AWS Lambda as a default will only allow you to process 1 request at any one time per active execution environment. Cloud Run differs because Cloud Run's allowing you to process, well, Paul's got it configured to 80 here. So that's 1 execution environment is going to process 80 concurrent requests. I guess that's more like a traditional application, right? Stuff running on Lambda is a bit of a paradigm shift when you think about it, when it's like one request at a time. So this is more akin to a traditional way of running an app.
Yeah, much more like just like a normal container environment.
In a container, yeah. What's the max you can set that to?
Oh, I'm sure it's huge. There you go, 1,000.
1,000, nice.
Yeah.
So you can set it down to 1 as well if you wanted to. If you wanted to, for some reason, only allow like to be like Lambda-like behavior, I suppose you could do that.
You can, and I've seen that done quite a lot actually.
Why would you do that?
Where the people that have things that are a little bit more like data processing jobs, or just depending how well they can write code that works concurrently. Yeah, so I have seen that down at 1, so they can kind of manage the instances.
Yeah. Because it's one of the interesting things about Lambda, isn't it? Like there's a whole bunch of programming challenges that kind of disappears, maybe the wrong word, but because you can guarantee at like a runtime level, you're only ever going to get 1 request at a once. It's like it does make some things potentially easier, also makes some things harder, of course. But
I mean, you're going to get more local caching, aren't you?
Yeah.
Within container, not that people should do that, but yes. Right. Okay. So I've done that. I'm going to click create. So
now what is that doing? That's going to be reaching out to Docker Hub, pulling the image.
And remember, at this stage, that image is just the server. It isn't a model.
That was just Ollama, wasn't it?
So it's just Ollama. It didn't have Gemma or DeepSeek or Llama in there. Yeah.
Okay.
So this will then provide you that kind of empty shell that you could then actually put a request in and ask it to then pull a model down. Yeah.
Yep.
Which again kind of shows why you wouldn't want it to disappear too quickly, because if it's again pulling a 10 gig model down, you don't want it just to disappear straight away.
So is there, while this is just loading them, what would be, so the first thing you showed us was using the Vertex AI Studio and making direct API calls. And now you're running Ollama inside Cloud Run. And if you were going to get to this, apologies, but why would you choose to run your LLM inside Cloud Run as opposed to just using like Bedrock or Vertex AI Studio or OpenAI directly?
So I think some of it would be you can run any model that Ollama can support. So it doesn't have to be like approved by Google. It could be a nightly version of it, if there is such a thing. You know, maybe one that's not been as thoroughly tested. It could be a model that you have trained yourself within your company.
Okay, yeah.
More likely one that you have fine-tuned yourself. So you've taken another model and then you've actually you've run it through a set of training to get it working, or where you've hooked it into a RAG database. So I'm going to forget what it stands for, but that's effectively where you give it an amount of data about your company, so that when you're searching it, retrieval augmented generation. So it's using, maybe the internal Confluence pages or internal Word documents, or, you've given it a library of information that it can query to help provide contextual data back to your company.
And I suppose as you're saying that, I'm immediately thinking the same question I asked when you were running it locally. If you're running Ollama and Model X inside Cloud Run that you own and you're connecting that to your own Confluence, nothing ever leaves your world, right? Is that fair to say? Would you say? I mean, I guess it's going through Google Cloud because you're running Cloud Run on Google Cloud, but I guess theoretically, is that all kept inside your own control?
Yeah, so I think as much as any container image that you run inside cloud providers is in your control. So, yes, that comes down to agreements and trust with the providers, but because they don't really know what you're running. For them, it's some code and some memory usage and some GPU usage.
Yeah, it feels more
contained.
I didn't want to use the word secure. Contained is the word. Like, rather than calling Vertex AI Studio, where that is a Google hosted API, here I'm hosting an API endpoint inside something I own, at least. Is how it feels to me.
Okay, so that's running away. I'll come back to that later, because what I wanted to kind of show is, and here I'm going to go through some other samples. So one way of running these models is to do what I've done, to run a relatively generic Alarma host kind of image, and then pull the models in at runtime. That's probably not going to provide a very good user experience. So the other thing that you can do is that you can actually pull the models in at build time. Okay, so I'm going to walk you through a Docker file, and what the Docker file is going to do is it's going to pull down a model of my choosing, and I'll pretend it's DeepSeek for this example, and it's going to pull that in as part of the build process, and it's going to put Alarma and the model into artifact registry, effectively Docker Hub, as a kind of a 5 GB blob, so that then when Cloud Run starts up, it's got everything already installed and configured, and you can just start to make requests against it. So,
yeah. So I guess just to reiterate then, so in the way you've got it running at the minute, it's going to pull that 5 gig image at the point someone makes an API call.
Yeah, so someone makes a call, it's not running, so Cloud Run's going to have to spin it up, and it's going to spin up Alarma. Yeah, but Alarma's pretty empty at that point. Yeah. And then it's going to be, okay, the API request is requesting a particular model. Alarma's then going to have to go across the internet to then pull that 5 GB model file down.
So what you're doing here is doing that ahead of time. So you're pulling down all the model stuff ahead of time.
Exactly that. So I'm using the Alarma image, which is the same one that we just saw. I'm setting up some variables, and then I'm doing a pull command on the model name that I've passed in. Yeah. So it's doing a serve, it's pulling the model down, and then at that point, it's taking a snapshot of the container image, and it's pushing it into the artifact registry. Perfect. I won't go into it in too much depth. The way that I've done that, there's a cloud build file. So this is effectively the build step that needs to take place to build the Docker image using that Docker file. The reason I've had to use something very slightly custom is just that I've given it a really high spec machine to be doing that, because it's got faster network access. So it'll just be a bit quicker to download the image over the internet. And let's try and see if I can get this working.
The joys of the live demo. You're a braver man than me.
Oh, this is, yeah. So there's a really nice UI called Open Web UI, and it gives you a lovely interface into these models. Really nice interface into the models. And I just cannot get it working today at all. It's just refusing, and its version numbers are right. Everything is correct. I cannot get it working. So
it's why, as much as possible, I try and avoid live demos of things. Unless it's on YouTube and I can pre-record it and edit it. But I think sometimes it's things always seem to be ever so slightly different than.
Yeah, no, absolutely, and yes, I couldn't.
Why I say you're a braver man than me.
could not agree more. So what I'm doing here is gcloud Google CLI. And build is using Cloud Build, their CI/CD tool. It's submitting a build to generate a Docker image. It's using the Cloud Build YAML file that I showed you. Which is slightly overly complex. It's using model name far too many times in here, but the model name we set to be Gemma 2. I'll use that one as a bit of an example. And actually what I can do then is I can go and look at.
And that build's running inside GCP.
It is, yeah. And we can see it running. So with Cloud Build, which is kind of nice, we can come in here and queued.
So while we're waiting for the queue to unqueue, then there was another question that came in which could be a interesting one, I think. But the question was from Lauren, how costly do you think something like this would be at an enterprise level? I mean, I guess, yeah, what does the pricing look like of doing something like this? Which feels like, a bit of a how long is a piece of string question, because I guess it depends on like how many requests, how big the models are, how much usage it gets. But do you have any thoughts on the pricing side of things?
Yeah, so it roughly looked like $1 an hour for one of these GPUs in Cloud Run.
And that's regardless of requests. So if that was if there's one request or 1,000 requests, or
that's per instance, okay? So a Cloud Run instance. So you could have those 80 requests coming in concurrently.
Yeah.
And as long as it's only hooked up to one GPU, you just get charged for one GPU.
And that's because of that instance-based pricing instead of that request-based pricing.
Yes.
Okay. So I guess, would it be fair to say that instance-based pricing gives you more predictable pricing? Because you could say, I know I've got one. You could limit it to one instance running. You could limit that to one GPU. You could have 80 concurrent requests, and you can pretty accurately predict then and say, hey, well, $1 per hour per month, 24 hours a day by 30 days, etc. You could reasonably accurately predict your costs.
Yeah, I think that's fair, but I mean, you could easily have this against a system that needs to handle 10 times the traffic it bursts. Mm-hmm. So I think managing of the min and max instances is crucial. I think that's the really key point. Mm-hmm. I don't know if you always put I forgot to start with this, but if anybody plays around with any of this, make sure you have billing alerts turned on. Please do it. I got caught out 2 weeks ago, not with GPUs. I just had an instance running for a couple of days. It was only $3 or $4, but it happens. I think enterprises will like this in the fact that you can have this set to 0 in your test environments, and it can scale to 0, and you're not being charged however many test environments you have. In production, then you can play around with your min-max instances to get it to a value that you want. So you've got enough that are warm. It's almost like a multiplier on a cold start. It's like a really cold start to kind of start some of these services up then. So you're just trying to play around, I guess, with the business and the performance. Now, I'm sure you can fill for a while, but I think I've got one that's already working. So if people are okay, it's kind of assuming that build will at some point come back. It takes about 6-7 minutes. I've then got a command to deploy that container. I'm not going to go into this too much because this is just what I did in the UI before. Okay. This is just setting 32 gig of memory. It's just setting 8 CPUs. It's setting it down to concurrency, in this case, 1, with a max instances of 1. So it's not doing anything that we haven't kind of seen via the UI. The one thing I will do, though, is Cloud Run and its authentication model. You can have it so that it allows anyone to make a request, which is fine. But obviously that, depending on the type of service. And with this, if you had someone prod you every 15 minutes, they might cause you quite a big bill. But for test purposes, I like leaving authentication turned on, and then you can run a little. No, the model name's not. Bear with me. I just need the model name variable. There we go. Okay. Again, that's far too small.
Thank you.
So I've just run this services proxy command, and what this does is it on your local machine opens up a port that will proxy into the running container Cloud Run instance, but adds the authentication on, and it works really nicely as well if you've got some of the private VPC kind of stuff configured. So that is making a request into Gemma 2 container, and you see here it says Alarma is running.
Yep. And that didn't seem crazy from like a cold start perspective.
Yeah, that was a cold start.
Yeah,
and it's about 5 gig image.
Yeah, that seemed pretty reasonable, I would say.
I kind of, you know me, I'm a fan, but I kind of like it. It seems usable. It seems like it would be usable. We're going to come back to
when
this
you do
later.
consider the size of the thing that you're doing. Like if that was like a web app, you'd be like a more traditional web app. You'd be a bit that was kind of slow. But given that you're loading what you're loading into a running container image, and I suppose I would, having never built like a LLM style chatbot style app, I would assume you're a bit more free from like a cold start perspective, because you're kind of expecting it to take a bit of time to think and respond, as opposed to like a web API where you want it just to respond quickly. So that felt pretty reasonable, I thought.
I kind of think it. Yeah, I kind of think it is. And again, you can play around with your min max instances. If you know you've got traffic coming in between 8 a.m. and 6 p.m., you can then change the, your profiles, etc.
Yeah.
And so the API column 8 was just to the root. So all that's doing is, that's not good. All that's doing is just saying effectively, are you running? This one is asking why the sky is blue. And the model isn't found, model ID.
Damn environment variables.
I know. Again, you try and make your demos relatively foolproof, but you're not going to fool. Give it a second or two. I might try changing the stream to true as well.
That was actually a question that Daryl asked earlier, and I was waiting to ask it. Sorry, Daryl, because I figured you'd get to it at some point. But Daryl did ask, does using Gen AI with Cloud Run support response streaming?
Should we try?
I like it. We'll test in real time.
There you go. Yes, it does.
Oh, wow, that's quite something.
Right, but it's just really difficult to read it.
Yeah. Yeah, there we go. Let's try and parse that from that response. But I guess if you were handling that with like a front end, like a web, like an app of some kind, you could parse that out, couldn't you?
But absolutely. And actually, I found a way of doing curl, so curl could scream to the JQ command to do it.
Nice. Okay.
I didn't quite get round to getting it working.
Yeah.
But so you can. But yeah, obviously it supports streaming. There you go. Yeah. Okay. And I could. I'm hoping that this. So if I change this to the last 15 minutes. Yeah. So instances running at 1, and I've got 0 at idle. Mm-hmm. Okay. So in the next 15 minutes, that active one will drop to being idle. Okay. Yeah. And then what have we got? So you've got some billable container time, you've got some CPU utilization, but then you've got some nice things down here. GPU usage.
When it's idle. So let me think about what I'm going to ask. If that container instance goes to idle and then it needs to start up again, does idle mean it's completely disappeared from the face of the earth? Or does idle mean it's going to spin up again quickly? Like, is it then cached, quote unquote?
So
here's one I made earlier. I like it, Paul.
Right, brilliant. Okay, so if you imagine a set of requests coming in, okay, the normal piece is this bit around CPU only during requests, right? So you can see that the requests come in, it spins some instance up, the CPU, you get charged, and then the red bit is where it's effectively warm. So it drops it down to a warm state. So it's ready for requests, but the CPU isn't kind of significant. It's not really being able to do anything. Request comes in, it ups the CPU. The memory is actually allocated all the way through this. It shouldn't say CPU and memory. Mm-hmm. But with the GPUs, it's effectively always warm. It's always ready to respond. Yeah. So the next request that comes in within that 15-minute block, you're going to get a quick response. Nice. Yeah. Yeah. That's not the perfect diagram to show, but it's the one I had to hand. Yeah. And then let's use this as because don't think it was refreshing quite. But on here, you can then start to get some nice GPU usage.
Okay.
So it looks like it's very close to the 20 gig limit. And I think this is because there's so many of the GPUs that have a 20 gig set of GPU memory that the models have been effectively manufactured to fit into the kind of standardized size GPUs.
That makes sense.
So yeah, this is it loading the model in, and it's just then, flat lines at effectively 100%, and then you can see the GPU utilization just popping up as it's actually processing then the requests.
Yeah, I mean, I suppose one of the big problems with running compute is fully utilizing your instances, right? You're kind of nailing this ball.
I mean, this diagram shows, I think, the reason why, that it's not worth them giving, kind of releasing the GPU to only then spin it back up again.
Yeah.
Expensive resources. Cool. Okay. That was pretty much it, James. So I think that was so I've tried to kind of show people a bit about local machine and Llama running on a local machine and how you can download models and run them locally. Didn't manage to show you the Open Web UI, although it's lovely. We've got you showing API calls.
Can you Google it? Show us what it looks like.
Oh, so yeah, go on then.
I just want to see.
It just makes it like a ChatGPT interface, but on your local machine.
Interface for all Llama, then I guess.
It's exactly that. It's exactly that. Yes.
Okay.
Do they have a screenshot? I mean, it's rubbish, isn't it? No.
Okay. Well, there we go.
Surely they've got something somewhere.
You'd have thought so, wouldn't you?
It's that without the thing behind it.
Yeah. So it's kind of So it's like interacting with any of the Anthropic or ChatGPT or anything like that. Okay. There we go. Yeah. Okay. Nice. Yeah.
Yeah. So where you can see Llama 3 latest, just up here, because you can have multiple models downloaded locally, that's where you can choose between the different ones. I believe it can actually download them as well, because it tells the Llama to go and download one, and so the Llama goes and downloads it.
Yeah.
And then it's got workspaces. It's got like prompt. You can save all your prompts. It can save your history. It can, it's a really nice interface when it works.
Yeah. Well, we can imagine that this is running. If you zoom in really far, we can imagine it's running on your machine, Paul.
Thank you. Cool.
Well, this. I mean, this has been really cool. I think one of the big conversations I've had with people in the past about AI, one of my personal big concerns about AI, not that it's a direct concern because of the nature of my job, but like exposing data to some of these models, some of these things, the fact that you can, I don't know, it feels to me like, kind of like what I was saying before, it feels to me like running a model yourself inside Cloud Run, albeit still running inside GCP, feels better than me sending data to OpenAI or to Anthropic or to DeepMinder. Is it DeepMinder? Anyway, doesn't matter. That it feels like a much more enterprisey approach without actually, and I guess this is where the serverless angle comes in, that you do that without needing to manage fleets of infrastructure. You've just got GPU on demand. You've got AI models on demand.
Yeah, and it's another one of those, isn't it? So the best solution here is to use a fully managed. I mean, yeah, if you're worried about the data side of things, if you're not, then use one of the fully managed models, because you can get an API endpoint, you can just call it, and you can get charged per call.
Yeah.
But if you wanted to do fine tuning, if you wanted to do RAG, a lot of these take a long time to build up your image, and then you're going to have to run it somewhere. And I just wince at the price of some of those big Gemini endpoints, you know.
So that would be your general heuristic, would it? For the most part, default to a managed model like Vertex, like Bedrock, like whatever Azure's version is. But if you've got any custom training required, you've got any custom stuff, then use something like Cloud Run and host all Llama in Cloud Run.
Yeah, and you're going to be using it for today until they announce any bigger instances. You're going to be using it for inference. You're going to be using it for the answering the questions. You're not really going to be using it for the training.
Which I guess is, Well, I don't know. I wouldn't have any. I guess anecdotally, I'd say most people interacting with AI from a dev perspective are usually doing inference, right? I don't imagine many of us are training custom models right now. Maybe that'll change at some point. Maybe that's what our jobs will become, just training models to write code for us. But I guess for the most part, that's what people are doing, isn't it?
Yeah, or we'll be training the models that do all of those things I talked about. You'll have your guard, and you'll have your, and you'll have your tester, and you'll have your, it just becomes ridiculous.
Yeah, awesome. I'll just open it up to any other questions. If anyone's got any questions. Andrew said Azure AI Studio is the managed service option from Microsoft, which is helpful. Good to know. Thanks, Andrew. Daryl said, what's Daryl saying? There are many legal IP concerns from company using Gen AI, dealing with himself. So I guess, Daryl, to ask a question of you that I want you to type really fast in the chat. Do you think something like using Cloud Run would negate some of them legal IP concerns, at least from like the conversations you've had with people you're dealing with?
It's nice. We need a streaming response from Gledhill.
yeah. One word at a time, please. Now, please make it easier to read than the terminal response that Paul got. There we go. Yes, Daryl. Some, but not really. Most. Interesting. So it sounds like it's just a general concern with using Gen AI at an enterprise level, which I kind of get. Like, yeah. Well, thank you very much, Paul. I've certainly learned a lot, and I've learned a lot about LLMs and Gen AI, and as well as Cloud Run. So I very much appreciate you coming and taking your time and doing this, as I'm sure everyone else did. Andrew certainly loved the session, as did Daryl. So we had some real-time feedback that this was super useful. So again, thank you very much, Paul. Thank you for everyone who tuned in and spent some time with us this afternoon, evening, morning, wherever you are. And we will see you all on the next one. Thanks, everyone. Thanks, Paul.
Thank you. Cheers, James.